Hello, good morning to everybody. I am Danilo Cole and I am the responsible of the explicit dynamic unit of NGSoft. Welcome to the Structural Optimization Packaging in a Green Context webinar. Okay, welcome and thank you for joining us today. We really appreciate your time and are excited to share insight and knowledge with you during this webinar. Engineers Danilo Cole and Claudio Martin will lead this webinar on green packaging, exploring sustainable materials, innovative designs, and efficient process to reduce environment impact and improve packaging performances. We will share expert insights and real-world application to boost your engineering workflow. Let's see topic areas. Today, sustainability is a key priority. Optimizing packaging structures is essential to reduce waste, lowering carbon footprints, and improving material efficiency. In this webinar, we will explore innovative strategies and technologies that allow companies to create eco-friendly packaging solutions without compromising functionality and performances. Learn how advanced design techniques, sustainable material, and digital CA tools can help streamline production process while minimizing environmental impact. Understand key strategies for structural optimization and explore best digital tools and technologies for optimizing packaging structures. We will also see some case studies and industry examples on real-world application and successful stories. This section, I can say that is perfect for a professional looking to stay ahead of industry trends and contribute to a greener future in packaging. At this point, I'd like to hand it over to my colleague Claudio Martin, who will continue the presentation. Claudio, please, it's up to you.
Thank you, Danilo. Good morning, everybody. I'm Claudio Martin, and I've been working on simulation on household appliance for about 10 years. And in today's presentation, I'll give you a brief overview of some of activity we follow on this topic. So we can start from this slide, and talking about the packaging, we have to consider that it has to protect the product in several phases, from production to delivery. In particular, once the product has been packaged, it remains in the warehouse for some time, where it is loaded and unloaded and then transported to the end customer. Each of these phases is analyzed with a so-called transport test, which assess if the packaging is suitable for the market. When a column, for example, of product remains stacked for a period of time, aging of the material occurs and creating a creep effect on the packaging that increases the slope of the column. In terms of product stacking, the simulation can be used to assess the inclination of the column due to material aging. And in case of excessive inclination, it is possible to redesign the packaging and virtually evaluate the improvement. Speaking of product angling, the evaluation test is called the clamping test, and this is carried out by clamping the gripper with a force of approximately 1,000 kilograms. This test evaluates loading and unloading from the truck and handling within the facility. At the end of this test, the product is unpacked and the aesthetic damage is assessed. Again, the simulation can provide guidance on how to redesign the packaging to ensure that the product is crushed in the most resistant area, avoiding damage to aesthetic or functional part. During loading and unloading, the product may be also subjected to fall or slip, which are described in the transport regulation as impact test. These are free fall from a certain height or slip on an inclined plane that cause the product to hit an hard surface. At the end of this test, the product must not show any aesthetical or functional damage. And as before, simulation can help to select the best packaging configuration by choosing from different geometry and material density. In this slide, show an example of a job carried out a few years ago on a freestanding kitchen. In the picture, you can see the deformation of the product with the original packaging and their correlation with the simulation. This deformation led to functional damage and also warranty claim, and this is why the customer asked us to optimize the packaging, with the goal to increase its protective performance and reduce the cost. These are the results of the optimization. Numerous designs were virtually tested to find the best compromise between cost and performance. As you can see from the table, optimization resulted in a reduction in aesthetic damage, a reduction in the number of parts, and a reduction in the mass of the PS. Taking into account the reduction in warranty cost and the saving in material and cycle time, the saving amount to more than €1 million per year. Here, speaking about green packaging, a current sustainability issue is the use of more recyclable material such as cardboard. In recent years, the advent of plastic taxation and more generally the theme of circular economy have led to the fact that more and more appliance manufacturers are asking us to simulate cardboard packaging, and so we have developed specific numerical methods. In order to simulate the cardboard, it's necessary to know its structure, starting with the composition, which identify the type of paper and the wave type, which specify the wave height and frequency. Is necessary to enter the mechanical property of the paper into a numerical code. And this involves obtaining stress-strain curve in the reference system of the material, and this is typically done by performing laboratory tests. To properly simulate our cardboard, a material calibration phase is carried out by performing both physical and virtual tests on the individual sheet, then on a sample, and finally on the whole component. Practically, these are tension and compression tests, wave crushing, and box compression tests. These tests are standardized and indicate the performance of the cardboard. Once the material is calibrated and our virtual model is properly defined, we are ready to start with the simulation. In this example, you can see the packaging of a cooker hood made entirely of cardboard, consisting of internal protective element and external box containing everything. Here you can see a free fall test from a specified drop height, which depend on the manufacturer's regulation. In the video, you can see the collapse of the wave during impact, which caused the packaging to absorb energy. Note how the folding of the box flaps has also been modeled to increase the accuracy of the virtual model. Speaking about optimization, we saw an example earlier where we redefined the geometry of foam in APS. In the case of cardboard, however, the optimization consists in redefining the fold of the cardboard protective element to control the way in which it deforms. You can see in this video how the right configuration, which we call crash box, has a more collapsible geometry and therefore transfer less impact force to the structure we want to protect. Also, for the internal side protection element, a crash box configuration was adopted in the optimization phase. As mentioned above, the greater energy absorption of the crash box configuration result in less permanent deformation of the product. In this image, you can see the difference in plastic strain on the product. Last image show a comparison between the real and virtual photo of the residual deformation of one of internal protection element. As you can see, there is a very good correlation. Thank you for your attention, and write any question by email, by our email. Thank you.